Hello everyone, let's take a look at LeetCode 269, Alien Dictionary. It's a very popular interview question, and Facebook has been asking this question for about 5 years. Okay, let's take a look at this problem now. So the problem is like there's a new alien language and we don't know the order of the character. We know in our world the order is A, B, C, D, E, F, G, but in this alien language, we don't know the order. So we are given a list of string words from the alien language dictionary. And where string words are sorted by order, right? By rules of this new language. So we need to return a string of the unique letters in this new alien language. And if there is no solution, we need to return empty string. And there also could be multiple solutions. We just return any of them is fine. So let's take a look at this example. Like WRT and WRF, then we can deduce T is before F. Then for WRT and ER, we can deduce W is before E. For ER and ETT, we know that R is before T. For ETT and FTT, we can deduce that E is before R. So this is one correct answer. Let's take a look at this example. From C and X, we know C is before X. From X and Z, we know X is before C. So there's a circle. C point to X, X point back to Z. So the order is invalid. We need to return an empty string. Okay, so looks like it's a very typical topological sort problem, right? So what we should do is, first of all, we need to build graph. As we analyzed previously, this is all the relationships between all the characters. So we can build such graph. So the code looks like this. We have graph data structure. It's a map. And the key is the character. The value is a vector of character. It's a direction, like directional graph. Okay, then we just for loop the words. For each word, we compare it with the previous words and deduce the order between the characters. But we also need to pay attention to some corner cases. Let's take this example. On IFTT and RFT, the first three characters are same. So RFTT should be placed after RFT, right? So for this input, the order is invalid. So we can just return empty string in this case. Okay, now we have the graph. We need to run topological sort algorithm. Normally, there are two ways to run the topological sort. One is DFS, one is something like in-degree and out-degree. Personally, I prefer DFS, so I will use DFS in this problem. Let's take a look at this words example. Like first, we need to check if there's a circle. If there's a circle, we should return empty string since the order is invalid. Okay. Normally, we will use the color method to check circle. So normally, a node has three states or three colors. 0 means this node has not been visited. 1 means we are currently visiting this node and its neighbors. It's currently in my DFS stack. Colors is 2 means we have already visited this node previously, so we will never visit this node again. So first we iterate all the words and iterate all the characters and initialize every character's color to 0 first. Next, we just for loop every entry in my colors map. If the color is 0, then I will just try to DFS it, visit this node and all its neighbors. And if there is a circle, I will return empty string. Okay, how can we check circle? We will use the DFS to check circle. For a node, at first, we set color to 1, means like we're currently visiting this node. This node is in my DFS stack. So I mark it as red, like here. We are currently visiting this node. Okay, then I will check every neighbor of this node. If the color is 0, which means I can visit that neighbor. So for B, the color is 0. So we are visiting B now. For B, C is B's neighbor, and colors of C is also 0. So we are visiting C. A is, now we are at node C. A is the neighbor of C. So we find this neighbor's color is not 0. The color is 1, which means node A previously is in our stack. Now I encounter it again. So there must be a circle. We should return true to indicate there is circle. So if has circle, I will return true. So for a node, it will check all the neighbors. As long as it encounter a visiting node, it will return true. And for all its neighbors, if they have circle, will also return true. Otherwise, all the neighbors are valid. We just mark the color to 2, indicate we have already visited this node. Then return false to indicate it's fine, there's no circle. Okay. Now we can correctly find if there's circle or not in our graph. Next, if there is no circle, we should return correct answer, right? Assuming we have this graph, A point to B, B point to C, we know the order is A, B, C. Like, how can we get this order? We just add one more parameter to DFS function called order. And at the end of our function, we just push the count character to my order. Then in my main function, I have a result. Here I have an order. I pass order to my DFS function. After DFS, I will reverse it and pre-append my order to result. Okay, let's take a look at example. We know if we visit A, then we will visit A's neighbor. Then we will go to C. Then we pop C. Before pop C, we add C to order. So C is at first. Then we add B. We pop B. We append B. Then we back to A. Then we pop A. We append A. So we order is CBA. Here we reverse CBA. So order becomes ABC. And we prepend ABC to the result. So result is ABC. Okay, which is correct. Okay, now some people may ask, what if we visit B first? Okay, if we visit B first, we know B, we come C, then we pop C, we pop B. So order is CB. We reverse order, pre-append to result. So result BC. Then I have for loop here. Next, I find, okay, C is visited. Then character is A. Okay, color is 0. We will DFS node A. Then order is A. Then we will pre-append the order to existing result. So result is ABC, which is also the correct answer. So it doesn't matter which node we like first visit or next visit. For topological sort, like no matter we doesn't care the order we visit each node. Like for random order, we always can get a correct topological sort answer. Okay, so assuming we have this graph, A point to C, B point to C. So we first visit A, then order is CA, result is AC. Then we visit B, order is B, pre-append B to result, so result is BAC. So for topological sort, we know that A point to C, B point to C means A must before C, B also should before C, but there's no edge between A and B. So it doesn't matter if A is before B or B is before A. It doesn't matter. Okay, so why does pre-append work? Since we know the new nodes, like the new order nodes we are visiting now, means these nodes, they haven't been visited by previous nodes. For example, we have two DFS here. This is first DFS. This is second DFS. For nodes in the second DFS, they haven't been visited by the they haven't been visited in the first DFS. So it's safe to append those to the front. Okay, next we can simplify it a little bit. We can just have result, then pass result, and reverse it. Finally, it's exact same as the previous solution. So we can also update it like we don't need to reverse it. In here, when we push back, we can just pre-append the character to orders. Then we don't need to reverse it. But sometimes the performance may not be very good. Using pre-append, we may always copy a new string here. Okay, so far so good. So this is a solution of alien dictionary. It's a very popular interview problem. So if you are not very familiar with it, you should practice it multiple times. Since there are also a lot similar, like such topological sort related questions in LeetCode. For example, something like cost schedule. The problem is like we have we have elementary math, also we have advanced math, and there are also a lot of other courses, and there's some dependencies. For example, if you want to learn advanced math, you should learn introductory math or elementary like math first. So it asks you to provide the order, like how we learn these courses. So it's also the very similar topological sort interview questions. Okay, that's it. See you next time.